Here's what truck dealers will never tell you when you're shopping for used pickups. What if I told you that 78% of truck owners experience major engine problems that cost over $5,000 within the first 5 years of ownership? That's not a coincidence. 78% get burned because they're buying trucks based on horsepower numbers and marketing claims, not actual reliability data. Picture yourself excited about that powerful diesel truck only to face catastrophic engine failure that costs more than the truck's current value. In this video, I'm revealing the 17 worst engines ever stuffed into American trucks that have destroyed more bank accounts than any natural disaster. And trust me, number one will shock you. It's an engine so notorious that entire forums exist just to help owners deal with its failures. Stay until the end, because this isn't just entertainment. It's your guide to avoiding the expensive nightmare that has left thousands of truck owners stranded with worthless vehicles and massive repair bills. Let's dive into the 17 engines that prove not every truck power plant deserves respect, starting from number 17, GM 6.5-liter Detroit Diesel, 1992 to 2001. The GM 6.5-liter Detroit Diesel appeared in Chevrolet CK series and early Silverado trucks from 1992 to 2001. This engine promised diesel efficiency, but delivered nothing but heartbreak. Owners reported cracked blocks, broken crankshafts, and constant overheating issues that made even light towing impossible. The fundamental problem was poor engineering from the start. The block design couldn't handle the stresses of diesel combustion, leading to catastrophic failures around 225,000 miles. The iron block was essentially a modified gasoline engine that wasn't properly strengthened for diesel duty. Reddit users consistently describe it as painfully slow and unreliable. The cooling system design was inadequate for the heat generated, causing frequent overheating that warped heads and cracked blocks. What made this engine particularly frustrating was its complete lack of power. Producing barely enough torque to move the truck itself, owners struggled to merge onto highways safely. Towing anything meaningful was out of the question, as the engine would overheat under even moderate loads. The repair costs often exceeded the truck's value, making these vehicles essentially worthless once problems started appearing. Many owners discovered that finding replacement parts became increasingly difficult as GM discontinued support for this failed experiment. Number 16, Nissan 5.6-liter VK56DE V8, 2004 to present. The Nissan Titan's 5.6-liter VK56DE V8 has plagued owners since 2004 with timing chain issues and a catastrophically flawed radiator design. The most notorious problem involves coolant mixing with transmission fluid due to poor radiator construction, destroying both the engine and transmission simultaneously. Timing chain wear creates rattling noises that grow progressively worse until complete failure occurs. The chain tensioners fail prematurely, allowing excessive slack that damages the timing chain guides and eventually the valves. The catalytic converter failures due to low fuel pressure compound the problems, creating a cascade of expensive repairs that can easily exceed $8,000. Nissan forums document countless transmission failures caused by coolant contamination, with repair costs reaching thousands of dollars. The radiator design allows pressurized coolant to enter the transmission cooler lines, turning automatic transmission fluid into a milky mixture that destroys clutch packs and valve bodies. Owners report discovering this problem only after both systems fail completely. The engine's complexity makes diagnosis difficult, and many mechanics struggle with proper repair procedures. Independent shops often misdiagnose the coolant contamination issue, leading to unnecessary transmission rebuilds before discovering the root cause. Owners report feeling betrayed by Nissan's reputation for reliability, as this engine consistently fails to meet expectations, while creating repair bills that often exceed the truck's remaining value. Number 15, GM 3.6-liter V6 LFX, 2015 to 2016. The GM 3.6-liter V6 LFX used in mid-size Chevrolet Colorado and GMC Canyon trucks suffered from timing chain stretch and inadequate oil cooling systems. This engine required oil changes every 4,000 to 5,000 miles to prevent catastrophic failure, far more frequent than advertised maintenance intervals. The timing chain stretch created rattling noises during cold starts and reduced performance over time. The chain would literally elongate under stress, causing timing to drift and eventually leading to valve contact with pistons. The poor oil cooling design meant the engine ran hotter than intended, accelerating wear on critical components and breaking down oil faster than normal. GM forums document numerous check engine lights and expensive timing chain replacements that often cost $3,000 to $4,000. The camshaft phasers would fail in conjunction with timing chain problems, requiring additional expensive repairs. Owners discovered that following GM's recommended 10,000-mile oil change intervals was essentially guaranteed engine destruction. The frequent oil changes and expensive repairs made ownership costs significantly higher than expected. Many Colorado and Canyon owners reported feeling misled about the engine's reliability and true maintenance requirements. Dealers often refused warranty coverage, claiming owner neglect despite following published maintenance schedules. The engine's problems became so widespread that GM quietly discontinued this particular version after just 2 model years. Number 14, GM 350 Diesel V8, Oldsmobile Diesel, 1978 to 1985. The GM 350 diesel represents one of automotive history's most catastrophic engineering failures. This rushed gasoline to diesel conversion used weak head bolts and lacked a water separator, causing head gasket failures and injection system damage. Most engines failed before reaching 80,000 miles, and many didn't even make it to 50,000 miles. The conversion process ignored fundamental differences between gasoline and diesel engines. The block wasn't strong enough for diesel compression ratios of 22.5 to 1, compared to gasoline engines running 8 to 1. The head bolt design couldn't maintain proper sealing under the extreme pressures generated by diesel combustion. Water contamination destroyed injection systems because GM failed to include basic water separation equipment that every other diesel manufacturer considered essential. The injection pump would fail when water entered the fuel system, sending metal debris throughout the fuel lines and destroying injectors. The weak head bolts would stretch under normal operation, allowing combustion gases to escape and coolant to enter cylinders. Owners nicknamed it the popcorn machine due to its excessive noise and constant failures that sounded like popcorn popping in the oil pan. The engine became so notorious that it prompted multiple class action lawsuits and Federal Trade Commission complaints. GM eventually offered engine replacements, but many owners had already abandoned their vehicles. El Camino Central forums document the widespread frustration of owners who felt betrayed by GM's promises of diesel efficiency. The engine's failure was so complete that it damaged GM's diesel reputation for decades. Number 13, Dodge 3.7-liter Magnum V6, 2002 to 2012. The Dodge 3.7-liter Magnum V6 used in Dakota and Ram 1500 trucks produced 210 horsepower but consumed fuel like a V8 while delivering none of the performance benefits. Valve seat failures and stuck lifters plagued this engine throughout its production run, creating expensive repair bills that often exceeded $4,000. Excessive heat generation caused rapid oil breakdown, with some engines requiring a full quart of oil every 1,000 miles. The single overhead cam design created hot spots that accelerated valve seat wear. When valve seats dropped, they would destroy pistons and require complete engine rebuilds. The engine's poor fuel economy made it an illogical choice for truck buyers seeking efficiency, often returning worse mileage than the available V8 options. The hydraulic lifters would stick due to oil sludge buildup, creating a distinctive ticking noise that indicated expensive repairs ahead. The cooling system design concentrated heat in critical areas, causing localized overheating that warped cylinder heads. Oil consumption became so severe that owners needed to check levels weekly to prevent engine damage. Owners reported frequent oil top-offs and complete engine failures before reaching 200,000 miles. The combination of poor fuel economy, high oil consumption, and reliability issues made this engine a triple threat of disappointment. Many owners wish they had chosen the V8 option for better performance and similar fuel economy. Forum discussions consistently describe this engine as Dodge's attempt to build a V6 that performed like a 4-cylinder while consuming fuel like a V8. Number 12, Chevrolet 6.2-liter Diesel V8, 1982 to 1993. The Chevrolet 6.2-liter Detroit diesel produced only 130 horsepower, making it severely underpowered for truck applications. Injection pump failures and harmonic damper problems created excessive noise and vibration that made driving unpleasant. The engine's low power output made highway driving dangerous, as trucks struggled to maintain speed on inclines. The injection pump failures occurred frequently, often leaving owners stranded. The harmonic damper problems created vibrations that damaged other engine components and made the driving experience miserable. Forum discussions consistently describe this engine as sluggish and prone to early failures. Owners reported feeling embarrassed by their truck's poor performance compared to gasoline alternatives. The engine's reputation became so poor that resale values plummeted, trapping owners in vehicles they couldn't sell. Number 11. Ford 3.5-liter EcoBoost V6, first generation, 2010 to 2016. The first-generation Ford 3.5-liter EcoBoost V6 in F-150 trucks suffered from timing chain stretching between 2010 and 2014, plus intercooler condensation issues from 2011 to 2012. These problems caused stalling and reduced power when owners needed it most. The timing chain stretching created rattling noises that indicated impending failure. Intercooler condensation caused sudden power loss and stalling, creating dangerous driving conditions. The engine's complexity made repairs expensive and time-consuming, often requiring specialized diagnostic equipment. Owners reported check engine lights and costly timing chain repairs that weren't covered under warranty. The intercooler condensation issues were particularly frustrating because they occurred without warning, leaving drivers stranded. Ford's initial denial of problems created additional frustration for affected owners. Number 10. Ford 2.7-liter EcoBoost V6, 2015 to present. The Ford 2.7-liter EcoBoost V6, introduced for fuel efficiency, faced carbon buildup issues from direct injection and premature timing chain wear. Early models were particularly problematic, with some owners experiencing complete engine failure before 100,000 miles. Carbon buildup from direct injection reduced performance and fuel economy over time. The timing chain wear created rattling noises and eventual engine damage if not addressed. The engine's complexity made diagnosis and repair expensive, often requiring specialized tools and knowledge. Some owners reported excessive oil consumption that wasn't covered under warranty. Later model improvements addressed many issues, but early adopters faced significant problems. The engine's reputation suffered despite Ford's attempts to resolve the problems through software updates and design changes. Number 9. Toyota 3VZE 3.0-liter V6, 1988 to 1995. Despite Toyota's legendary reliability reputation, the 3VZE 3.0-liter V6 used in Toyota pickup and T100 trucks suffered from chronic head gasket failures after 100,000 miles. This engine also experienced persistent overheating and oil sludge problems while producing only 150 horsepower. The head gasket design couldn't withstand normal operating stresses, leading to coolant leaks and overheating. Oil sludge accumulation clogged passages and accelerated wear on critical components. The low power output made the engine feel inadequate for truck applications, especially when towing or hauling. Toyota owners felt particularly betrayed because they expected better reliability from the brand. Repair costs often reached thousands of dollars for head gasket replacements. The engine's problems damaged Toyota's reputation and led many truck buyers to consider other manufacturers for the first time. Number 8. Dodge 4.7-liter V8, 1999 to 2013. The Dodge 4.7-liter V8 used in Dakota and Ram 1500 trucks from 1999 to 2013 suffered from valve seat failures and oil sludge accumulation. The cooling system design exacerbated these problems, making long-term reliability nearly impossible to achieve. Valve seat failures occurred without warning, often causing complete engine failure. Oil sludge buildup clogged critical passages and accelerated wear on moving parts. The cooling system design couldn't adequately manage heat, leading to warped heads and engine overheating. Owners reported frequent overheating issues and expensive repair costs. Some engines required complete replacement before reaching 150,000 miles. The combination of multiple failure modes made this engine particularly frustrating for owners who expected better reliability from their trucks. Now, before we continue with our countdown to the absolute worst truck engine ever created, if you're finding value in these warnings, consider subscribing to stay updated on the automotive disasters you need to avoid. We research hundreds of engines to bring you only the most critical information. Number 7. Nissan 5.0-liter Cummins V8 2016 to 2019. The Nissan Titan XD's 5.0-liter Cummins V8 was marketed as a powerful diesel solution, but failed to deliver promised fuel economy while suffering from turbocharger and EGR failures. A recall affected 12,000 trucks, with engine replacement costs quoted at $35,000. The complex emission system created constant problems that kept trucks in service bays instead of working. Turbocharger failures occurred prematurely, often before warranty expiration. The EGR system failures triggered check engine lights and reduced performance, making the trucks unreliable for work applications. TitanXDForum.com documents crankshaft fractures and DEF system issues that cost owners thousands in repairs. One user reported spending $2,500 on EGR repairs alone. The engine's complexity made finding qualified repair technicians difficult, increasing costs and downtime. Number 6. Chevrolet GMC 5-cylinder Atlas 2004 to 2012. The inline 5-cylinder Atlas engine used in Chevrolet Colorado and GMC Canyon trucks was an engineering oddity that vibrated excessively and suffered from persistent oil leaks. The unique design made finding qualified mechanics difficult, increasing maintenance costs significantly. The odd firing order created constant vibration that made driving unpleasant and accelerated wear on other components. Oil leaks were common and difficult to diagnose due to the engine's unusual configuration. Mechanics unfamiliar with the design often misdiagnosed problems, leading to unnecessary repairs. J.D. Power reliability ratings for the 2008 Colorado and Canyon dropped to 47 out of 100, reflecting widespread owner dissatisfaction. Top speed user reviews consistently mention a noticeable shudder while driving and cooling system issues. The engine's unusual design made parts more expensive and harder to find. Number 5. Ram 3.0-liter EcoDiesel V6 2014 to 2023. The Italian-sourced Ram 3.0-liter EcoDiesel V6 promised efficiency, but delivered frequent EGR and turbocharger failures that kept check engine lights constantly illuminated. Engine seizures occurred as early as 30,000 miles, with replacement costs reaching $30,000. The EGR system design was fundamentally flawed, creating carbon buildup that blocked passages and caused overheating. Turbocharger failures occurred without warning, often causing additional engine damage. The emissions control system was so complex that many repair shops couldn't properly diagnose problems. Ram EcoDiesel forums document extensive owner frustration, with one user reporting a seized engine at 57,000 miles that cost $14,500 to repair. The repair costs often outweighed any fuel savings, making the diesel option economically senseless. Many owners wish they had chosen the gasoline V8 instead. Number 4. Chevrolet 5.3-liter V8 with AFM 2007 to 2013. The Chevrolet 5.3-liter V8 equipped with active fuel management used in Silverado and GMC Sierra trucks suffered from excessive oil consumption and lifter failures. The AFM system, designed to improve fuel economy, actually caused premature wear and costly repairs. The AFM system's operation created uneven wear patterns that destroyed lifters and camshafts. Oil consumption became so excessive that owners needed to carry extra oil for long trips. The system's complexity made repairs expensive, often requiring complete engine disassembly. Aftermarket companies developed bypass kits to disable the AFM system, indicating the widespread nature of the problems. GM forum users reported needing to add oil frequently, with some experiencing lifter failures before 100,000 miles. The fuel economy benefits never materialized due to the system's poor reliability. Number 3. Ford 6.4-liter Powerstroke Diesel V8, 2008 to 2010. The Ford 6.4-liter Powerstroke, used in Super Duty trucks from 2008 to 2010, was designed to meet stricter emission standards, but suffered from complex dual-turbo system failures and radiator problems that often led to complete engine failure. The dual turbocharger system was overly complex and prone to failure, often taking the entire engine with it when problems occurred. Radiator failures caused overheating that warped heads and cracked blocks. The emission system created so much heat that cooling systems couldn't cope with normal operation. Repair costs frequently exceeded $10,000, severely impacting resale values and owner confidence. FordTrucks.com users describe the engine as universally disliked due to its high maintenance costs and frequent breakdowns. Owners reported cracked pistons and EGR cooler failures that made the trucks unreliable for work. Number 2. Ford's 6.0-liter Powerstroke Diesel V8, 2003 to 2007. The Ford 6.0-liter Powerstroke, used in Super Duty trucks and excursions from 2003 to 2007, is often cited as one of Ford's worst diesel engines ever produced. Head gasket failures, clogged oil coolers, and faulty injectors led to repair costs often exceeding $10,000. A class action lawsuit resulted in over $10 million in payments due to fraud allegations related to the engine's problems. The oil cooler design was fundamentally flawed, causing overheating and head gasket failures. Injector problems created rough running and expensive repair bills that destroyed owner confidence. Powerstroke.org forums highlight extensive owner frustration, with one user noting a cracked head at 35,000 miles and repair costs nearing $10,000. Shop visits became so frequent that many owners traded their trucks rather than continue fighting the problems. The engine's reputation became so poor that it affected resale values across Ford's entire truck lineup. Number 1. Ford 5.4-liter Triton V8, 1997 to 2010. The Ford 5.4-liter Triton V8 takes the top spot as the worst truck engine ever produced. Used in F-150, F-250, F-350, and Expedition vehicles from 1997 to 2010, this engine is notorious for spark plugs literally blowing out of the cylinder heads due to insufficient thread depth in early models. The spark plug ejection problem occurred because Ford used only 4 threads to hold the plugs instead of the industry-standard 8 threads. The aluminum cylinder heads couldn't maintain proper thread integrity under the extreme pressures of combustion. When plugs ejected, they often took pieces of the cylinder head with them, requiring expensive repairs that frequently exceeded $5,000 per incident. The timing chain problems were equally devastating. The plastic timing chain guides would break apart, allowing the chain to jump timing and destroy valves, pistons, and sometimes the entire engine. The 2-piece spark plugs would break during removal, leaving the threaded portion stuck in the cylinder head. Special extraction tools cost hundreds of dollars, and many plugs still required drilling and thread repair. Fuel pump failures occurred with alarming frequency, often stranding owners without warning. The pump would fail internally, sending metal debris through the fuel system and contaminating injectors. The National Highway Traffic Safety Administration received thousands of complaints about this engine, creating one of the largest databases of owner complaints in automotive history. Ford issued special tools to address spark plug issues, but the damage to their reputation was already done. Ford truck enthusiasts, forum users, described the engine as a money pit due to recurring spark plug and timing chain repairs. The 2004 to 2007 models were particularly problematic, with owners reporting frequent misfires and engine knocking that indicated impending catastrophic failure. Some owners experienced multiple spark plug ejections on the same engine, making their trucks essentially worthless. The repair costs often exceeded the vehicle's value, trapping owners in trucks they couldn't afford to fix or sell. Insurance companies began totaling vehicles with spark plug ejection damage because repair costs exceeded reasonable percentages of vehicle value. This engine single-handedly damaged Ford's reputation for decades and sent countless truck buyers to competitor brands. Speaking of engineering disasters, you need to see the 17 worst car engines of all time. Some make these truck engines look reliable. These truck power plants destroyed bank accounts, but the repair bills from these failures pale compared to what's coming next.